All right, RMS Algebra. Welcome to another video lesson here. This one today will be a review of the properties of exponents that we've been working on all throughout this course. I know by this point we've been seeing them for quite a while, and I'm hoping many of you are feeling really confident with them. However, I do still see mistakes happening on our tests when we have things like this on there. So let's take today as an opportunity to just review some of those ideas a little bit. So a couple important things to start out with, and those are just some of the facts that we've learned. And one of those is the fact that x to the negative first power is equal to 1 over x, or 1 over x to the first power, although we don't write it. And that's something that we really will need. We proved that to ourselves using different examples. We would say, okay, what if we had x to the fourth over x to the fifth? Well, if we use our shortcut of subtracting the exponents, which is what we do when we divide, we'll see that we have x to the negative first, because 4 minus 5 is negative 1. However, if we take that same idea and we expand x to the fourth to be x times x times x times x, and then we do x to the fifth in the same way, we can start dividing out or canceling out any x that matches up with 1 in the numerator and denominator, because that's just a 1 when it divides. And what happens here is everything divides out to be a 1 except for the remaining x on the bottom. We have a 1 in the top still, because that 1's just a placeholder, but we see that x to the fourth over x to the fifth is also 1 divided by x. So x to the negative first is the same as 1 over x. That's a fact we'll need. It also holds true. X to the negative fifth would be the same as 1 over x to the fifth. So any negative exponent can be made positive by going to the bottom of a fraction. And we can actually reverse things if we have 1 over x to the negative second. That's actually equal to x to the second. So it goes both ways there. So that's an idea you definitely need to be successful with exponents. Another fact that we've learned was that anything to the 0 power was always going to be equal to 1. And we could do a similar thought process like we did for our negative exponent relationship. If we had x squared over x squared, well, anything divided by itself is always 1, but then we could also look at it, okay, if we do the subtraction of the exponents, that would mean 2 minus 2. Well, that gives us x to the 0. So it's equal to 1 and it's equal to x to the 0. That's another important fact that we'll need to be successful with exponents. So with those things in mind, let's review some of the different situations that might show up when working with exponents. If we look at a basic example where we're multiplying something like b squared times b to the fourth, well, we know those could be expanded. B squared could become b times b, and b to the fourth would be b times b times b times b. Well, that simplifies to b to the sixth power, which we could have arrived at just by adding 2 plus 4. And that's always going to work. We can add the exponents when we multiply. We've already talked about what we can do when we divide, and that's we can just subtract those exponents, because a to the third could be expanded. A to the first is already expanded, so we'll have 1 cancellation, and we'll get a squared, which is the same as 3 minus 1. So we can use those shortcuts frequently. Another important fact is what happens when we group things with parentheses. So if I have a squared to the third power, that's actually equal to a squared multiplied by a squared multiplied by a squared again. Well, I know that I can add the exponents when I multiply, so that's a to the sixth. But it turns out 3 times 2 is a shortcut to arrive there. So if we multiply those two exponents, we can get that 6 as an exponent on a. Things get a little more tricky once we start adding numbers as well. So if we have something like 2 times a squared all to the third power, well, it turns out that not only is that third power going to be on a squared, but it also happens with a 2, because this is the same as 2 times a squared multiplied by 2 times a squared multiplied by 2 times a squared. We know that multiplication has the commutative property, so we can change the order and do 2 times 2 times 2 times a squared times a squared times a squared, which ends up being 8a to the 6th. Now, to save us all that work of expanding, we could still do 3 times 2 to get that 6 for the exponent on a, and we could also do 3 multiplied by the 1, that's the exponent on 2, to see that we have 2 to the third power, which is 8. So we could use those instead of having to expand to be able to work with grouping. To look at things as they get even more complex, let's look at some division with numbers and multiple exponents. So here we have 4 over 2 xy, or 4xy to the fourth over 2x squared y, excuse me. When we're working with that, well, 4 and 2 can be divided or simplified just like you always would. So 4 divided by 2 is 2. We could write it as 2 over 1 if you want to keep that 1 as a placeholder. But that's just basic math. Notice I didn't do subtraction. I said divided. So 4 divided by 2 was 2. We only subtract when we have exponents that we're working with. So now we can continue and we can subtract some exponents. I know there's a 1 on my x, even though it wasn't written originally. So I can do 1 minus 2 to simplify that. So now it'll be 2, and then 1 minus 2 is actually negative 1. My y's I didn't do anything with yet. So I'll have simplified it to this point, and then I can subtract the exponents on the y's. Remember, there's a 1 on this y as well. So I'll end up with 2 multiplied by x to the negative first multiplied by y to the third power, because 4 minus 1 is 3. So I've simplified that, and then all that can be considered over 1. And the reason that's important is because I want to get rid of my negative exponent. To do that, that rule of flipping it to the bottom and making it positive still works. So my final answer can be written as 2y cubed, all divided by x to the first power, or just x. Notice I didn't rewrite that 1 because it was just a placeholder, and 1 times x is just x. So that would be the simplified answer there. Other things that we might run into, something like 2b cubed all to the negative second power. Well, that's equal to 2 to the negative second multiplied by b to the negative sixth. And then to make that positive, I could write that as 1 over 2 to the negative second times b to the negative sixth, or 1 over, oh boy, what's 2 to the negative? I see my problem. When I flip to the bottom of my fraction, those really shouldn't be negative anymore. They should be positive. And that's what allows you to work with negative exponents. That's why we want to be able to flip them. So now I can do 2 squared and get 4. And then b to the sixth just remains the same. So that's one approach we could look at. We could also rewrite this as 1 over 2b cubed all to the positive second power right away, and then we could use our shortcut to get to the same point. So you have 2 different ways you can approach those. The last thing that we've seen with exponents is just working with scientific notation a little bit. So if we have something like 3.0 times 10 to the fourth all over, let's go 6.0 times 10 to the negative fifth, we can simplify that problem as well. Remember that x that's written here, that's actually multiplication for my scientific notation. But we can do division on 3 and 6, and we could write that as 0.5 on the top. And that's just because with scientific notation, I don't really want anything in the bottom of my fraction or in the denominator. So 3 divided by 6 is 1/2 or 0.5. And then 10 to the 4th divided by 10 to the negative 5th, we subtract our exponents. So 4 minus negative 5, that's like 4 plus 5. So we'll get 10 to the 9th there. So we've simplified things, but we haven't officially written in scientific notation yet. So we should do one last step, which is to write this as 5.0. So what I did was I moved my decimal place 1 to the right. So I made that a larger number, which means that my 10 shouldn't be to the 9th power anymore. It should only be to the 8th because I moved that decimal place 1 to the right. So right now I've simplified that using my exponent rules, and it's written fully in scientific notation. All right, those are key ideas we've seen throughout the year that I thought were really important to review. Please use this video to help you complete the homework assignment, which is the worksheet linked on Google Classroom. For that, read the instructions carefully. You're only asked to do the even problems, so don't do all of them, just the evens on that worksheet. If you run into any problems, remember there's office hours from 9 to 11, so please use those on Google Classroom, and I'll answer those questions right away. All right, class, good luck.